I'm going to go over an orthogonal trajectories problem. It's problem number 26, Trench Textbook, section 4.5. You need to find the orthogonal trajectory of the family of curves x squared plus 4xy plus y squared equals c. Alright, so the first thing you would do is implicitly differentiate. So the derivative of x squared is 2x, plus the derivative of 4xy, which is a product rule. So the derivative of x is just 1, so it'll be 4y, plus derivative of y times 4x, so it'll be 4x times dy over dx, and plus the derivative of y squared, which is 2y, times dy over dx equals 0. Cleaning this up a little bit, factor out dy over dx. 2x plus 4y plus dy dx times the quantity 4x plus 2y still equal to 0. Separating the dy dx, we would get dy over dx equals negative, the entire thing is negative, 2x plus 4y over 4x plus 2y, or canceling out the 2's, you get negative x plus 2y over 2x plus y. This will be our f1, and now to find the orthogonal trajectory, or f2, you would take the negative reciprocal of the f1, which in this case would be dy over dx equals positive 2x plus y over x plus 2y. What we have here is homogeneous, so we can multiply or divide everything by x and then use u substitution. So dy over dx equals 2 plus y over x over 1 plus 2 times y over x, in which we make our substitution. U equals y over x, and y would equal ux. So dy over dx would equal u plus x times the du over dx. That would be the product rule. Substituting everything in for dy dx, you get u plus x times du over dx, which equals 2 plus u over 1 plus 2u. Now, we subtract over to u, so you get x times du over dx equals 2 plus y over 1 plus 2u minus, and then finding the common denominator, you get u times quantity 1 plus 2u over 1 plus 2u. So we add those together, you will wind up with x times du over dx equals minus 2 times the quantity u squared minus 1 over 1 plus 2u. Excuse me. The easiest way to separate the variables here would be to take the reciprocal of everything. So we get 1 over x times dx over du equals 1 plus 2u over, factoring out a minus 2, we actually already did that, we get minus 2 times u squared minus 1. Multiplying up the minus 2 to clean it up a little bit, minus 2 over x times dx over du equals 1 plus 2u over, factoring the bottom, u plus 1 times u minus 1. Moving the du over, we can now integrate both sides. So the integral of minus 2 over x times dx equals the integral of 1 plus 2u over u plus 1 times u, it should be u minus 1, times du. Which we have here is the partial fraction decomposition here. So 1 plus 2u over u plus 1 times u minus 1 would equal a over u plus 1 plus b over u minus 1. So we multiply across, we get 1 plus 2u equals a times u minus 1 plus b times u plus 1. The essentially cross multiply. So to first cancel out the a term, we can use u equals 1, which would have us at 1 plus 2 times 1, which is 3, which equals b times 1 plus 1, or 2. Dividing by 2, you would get b equals 3 halves, and doing the same with a negative 1, we can cancel out the b's. That would be 1 plus 2 times minus 1, or 1 minus 2, which would equal minus 1, which equals a times minus 1 minus 1, which is minus 2. Dividing by minus 2. You get a equals 1/2, and now we can substitute back in, and we can integrate. Okay, so here we got the negative. Pulling the negative up front, you got the integral of 2 over x dx equals 1/2 of the integral of 1 over u plus 1 du plus 3/2 of the integral of 1 over u minus 1 du. We can multiply everything by 2, clean up the fractions, which equal to negative the integral of 4 over x dx equals the integral of 1 over u plus 1 du plus 3 times the integral of 1 over u minus 1 du. And then integrating both sides, we get negative 4 times natural log of the absolute value of x plus c equals natural log of the absolute value of u plus 1 plus 3 times, pulling the coefficient down, the natural log of absolute value u minus 1. And to clean everything up, we can take the exponential of both sides to clean up the natural logs. But before we do that, we can pull the coefficient up front in as an exponent. So we would have the natural log of the absolute value of x to the minus 4 plus c equals the natural log of the absolute value of u plus 1, the coefficient would be 1, plus the natural log of the absolute value of the quantity u minus 1 to the third power, pulling the 3 in. So now we can take the exponential of both sides and get rid of the natural logs. We are left with 1 over x to the 4th, or x minus 4, x to the minus 4, excuse me, times c equals u plus 1 times u minus 1 to the third power. And now finally, substituting back in y over x for u, you get c over x to the 4th equals the quantity y over x plus 1 times the quantity y over x minus 1 to the third power, which would yield the orthogonal trajectory of c equals y plus x, where we just multiply all terms by x, times the quantity y minus x to the third power. And then if we pull up our graph EQ, we can indeed see we got x squared plus 4xy plus y squared equals c, and c equals y plus x times y minus x to the third power, and we can confirm that both of these family of curves are orthogonal at all points of intersection, meaning that these answers are correct. Thank you for watching.